Well, welcome back, this time to recording 1C for our series on angles and standard position, Unit 2, Chapter 2, Trigonometry in Mathematics 2200. In this one, we're going to be looking at angles of rotation and standard position having the same reference angle. And we'll be doing that by looking at them as a series of reflections in the x-axis and the y-axis. Angles of rotation and standard position with the same reference angle can be thought of as reflections of each other in the x and y-axis. And we'll take a closer look at that now with a demonstration. In this example, we've got a 49-degree angle in our first quadrant. It has a reference of 49 degrees, and the standard position angle itself is 49 degrees. We want to create angles in each of the other three quadrants with the same reference angle. I'll begin by marking my line of reflection will first of all be the y-axis, and I will reflect this terminal arm in that y-axis. Doing that, my terminal arm winds up over here, and we now have an angle with the same reference angle, 49 degrees. I can show my line the direction of reflection with a dotted line. It shows me that I've reflected from point P here over to this new position using this line or this direction of reflection across the y-axis. I can then take that new angle, that new terminal arm, and reflect it across the x-axis. And when I do that, I will get this new terminal arm. It has the exact same reference angle as the other two angles I've already constructed. My line of reflection is I'm going across the x-axis, so I am reflecting vertically across the x-axis. Next, I can take that terminal arm. I can reflect it across the y-axis again, the negative part of the y-axis, and I will get a terminal arm in this location, and again the dotted line just shows that I've reflected across the y-axis. Now another alternative would have been to take that initial angle that I had in quadrant 1 and reflect it in the x-axis instead. So instead of starting with the y-axis like I did, I now reflect it in the x-axis. And I could have reflected vertically. So to summarize all those reflections, I could have reflected across the y-axis, then take that one across the x-axis, then take that one across the y-axis, and then I can go back across the x-axis again. Now, one other thing we can do is if we hide the line of reflection across the top that showed a reflection in the y-axis, and we hide the one on the bottom, the reflection in the y-axis down there, I can see that my four angles form a perfect bow tie. So for that reason, sometimes angles, the four angles that have the same reference angle are known as, somewhat informally, they're known as bow tie angles. So you'll see here we have a diagram that summarizes those reflections that we did and the fact that we can get a and we can form a perfect bow tie from the 4 angles that have the same reference. In summary then, the terminal arm of an angle theta in standard position can be reflected in the x-axis or the y-axis to obtain another angle having the same reference angle.